lot of choices to be made when designing a Flux application. And this presentation is about some of the choices my team made and some of the choices we could have made instead. How many of you use Flux like at work? Is there anybody in here doing that? Okay, great, cool. And how many of you have just messed around with it? Like, just played around, seems like? Okay. How many of you use React at work? Okay, so we have a fair number of React people in here. Okay, cool. So, I love React. I see in Keynote, that black matches right there. The black of the little symbol matches the black of the presentation. It doesn't match here. Anyway, so I love React. In 2013, I started playing with Angular, and it kind of blew my mind. It was like the first time I'd used something like that. And then 5 days later, of course, React showed up on the Hacker News front page. And so I had to try it out too. And probably a few hours into using React, I realized I was done with Angular, over it completely. React was the new thing for me. I think what I liked most about React compared to Angular is that React is not a very opinionated tool, right? It just handles the view layer of your application, and it's not very prescriptive about what to do outside of that. By early 2014, I was seriously using React in kind of all of my new projects. And then at the beginning of this year, I started working for Rock Solid Internet. So Rock Solid, what they do is they provide an integrated shipping solution that's cross-carrier, so think shipping UPS, FedEx, DHL, freight, things like that. And when I arrived at Rock Solid, they were already a few months into their first Flux project. So at the time, I knew that Flux was a thing, but I hadn't read anything about it. I'd been happily building React apps, just doing things my own way. So Flux was introduced by Facebook in 2014. It's sort of their answer to the question, how should I structure a React application? Right? Flux is a pattern, like MVC. There's no official Flux framework. Basically, what Flux is advice from Facebook. After going through the Flux tutorials, I could immediately see some good things about it. Right? Like, it was obvious to me from the beginning that I needed to move my state outside of my React components. My original React applications tended to have all of the state kind of clustered in some component near the top, which was fine, but I could tell that was probably a little bit fragile and I needed something better. And Flux seemed like a good answer to that. And then it was nice to know that state changes only occur within stores during the dispatch cycle. So that's something I think that's pretty clever about Flux, is like keeping track of the changing state of your store. It can be pretty difficult. And knowing that your stores will change in a predictable order, in a predictable fashion, only in one particular cycle during a dispatch cycle is nice. And then I like the fact that Flux sort of has a lightweight concept of models and collections. It's not particularly opinionated about that fact. But there were some things that were confusing initially as well. One thing that really was sort of bugging me at first when we started doing the Flux thing was how should we name our action types? Like we had a few small examples like the to-do MVC application to base our application on. And I don't think that we were doing a very good job of naming our actions. Like we had actions named like get shipment or things like that. And it was kind of confusing. They seemed almost just sort of like methods or commands that you were sending to the stores. And that I didn't quite grok the whole point of it. And then another thing we wondered about was how should we split up our stores? At first we had a bunch of little tiny stores and then one really big store. And we knew that the big store needed to be split up, but we didn't have a lot of insight about how to do that. Also at the beginning, we were kind of confused about wait for, actually, and this has a little bit to do with that action naming thing. We were, all of our actions were sort of targeted at one store or another. We didn't have any actions at first that more than one store needed to respond to. So wait for seemed like a complicated concept that we didn't see a use for. And then another big problem that we had was it wasn't clear to us how Flux was supposed to work with React Router. You know, in your Flux application, your Flux stores are kind of supposed to be the single source of truth for the state of your application. But we had React Router going at the same time, and it sort of had its own source of truth about like what route we were on. And we weren't quite sure how to get those two things to play nice together. At that early stage, we were doing our best to muddle through, and we figured that we would get better as we went along. But then we ran into a question that stumped us. So we had this complex form. That's what passes for a complex form. We had this complex form, and it was continuously validated as the user made changes. And anytime there was enough information in the form to go get a new quote, we wanted to trigger an Ajax call that would go get that quote, right? So any of the input fields could result in that Ajax call being triggered because any of the input fields might be the change that resulted in the field being valid. And to clarify our problem, why this was stumping us, here's a quick refresher on Flux action creators, right? So a typical trivial action, right? User interaction will trigger an action creator, and the action creator will send an action to the dispatcher, and then the dispatcher will distribute that action to the stores, right? And that's all synchronous. That's like a simple, very trivial action. An Ajax action creator, though, this is something you'll see in the examples all the time, like might dispatch a loading action at first and then also trigger an Ajax call at the same time. So like we might have this view shipment action creator that tells the stores, okay, we're loading, and then it triggers an Ajax call. And then when the Ajax callback gets done, it tells the stores, okay, we've loaded and here's the shipment you're looking for, right? So we dispatch, trigger Ajax, and then dispatch again. And it kind of always does this every time you use this action creator. But our problem is, our thing was sort of an Ajax action with a twist, right? It looked really similar. We had this action, this change field action, and that would always dispatch the change action to the store. But then we only conditionally wanted to actually trigger the Ajax, right? And the problem that we were running into, to understand why we were stumped, is because we were looking at this diagram here. This is from Bill Fisher's July 2014 blog post explaining actions in the dispatcher, right? So Bill Fisher is not the creator of Flux, but he's often its spokesperson. The creator of Flux is actually Jing Chen, another Facebook engineer. And if you take this diagram to be the whole story about Flux, you'll notice two things that were problematic for us in this particular case. First, it looks like only action creators are supposed to ever trigger any sort of Ajax. And second, it looks like the only way for the action creators to know about data inside of the store is through the React views, through user interaction, right? And this was problematic for us because our store knew that the form was valid and that we needed to go get a new quote, but it looked like it wasn't supposed to go get the new quote. And our action creator told the store about the input, but it couldn't read from the store to find out if it was time to go get a new quote. At least that's what we thought based on this diagram, right? So this led to some considerable anxiety on my part. We could think of ways to make it work, but we didn't know if those were proper Flux, right? And to some degree, this anxiety was due to the fact that as a team, we still couldn't always clearly articulate why Flux was a good idea, right? We were just sort of doing it because Facebook had given us this advice and it seemed like we should take Facebook's advice. So at this point I turned to Google looking for answers. And this was my first contact with what someone has called the Flux Anarchy. So you Google for these things. Should action creators read from stores? Should stores initiate Ajax calls? Should action creators return promises? That last one actually had to do with a problem that we were dealing with React Router, but it was another one of the things that we were sort of stumped by. And if you Google these things, you get lots of Stack Overflow questions and lots of GitHub issues, and there's a lot of contradictory answers and lots of opinions, and people don't agree with each other, and they sort of see it working different ways. I mean, at this point, I feel like I really know the answers to these questions, right? Should action creators read from stores? Sure, yeah, that's fine. Should stores initiate Ajax calls? Yeah, you can do that too. Some teams do that. Should action creators return promises? No, probably not. That probably means you've got something funky going on. But the only reason I feel so confident in these answers is because I actually went and read every single issue in the Flux GitHub repository and looked for every single issue that had to do with people asking, how do I do async? How do I do this kind of thing? Can I read from the stores in my action creator? And I cataloged all of Bill Fisher's responses. And so at that point I felt pretty comfortable, like I knew what was going on. But what's amazing is that the Flux website still doesn't actually directly address these things. So if you're new to Flux and you're just reading the stuff on the Flux website, you'll probably run into the same problem that we did, and you'll be stumped by it. But back in March, it didn't occur to me to just read all of the issues in the Flux repository, and so without any definitive answers, we kind of felt like we had to make our own way. So this is what Flux looks like at rock solid based on the decisions we've made over the year. So we gave all of our action types past tense names to keep them from looking like commands. Then we started initiating Ajax from stores. Now we added a RouteStore and a changed route action, and we removed Boilerplate by auto-generating action creators for simple actions. So I'm going to go through these things one at a time and sort of explain our motivation behind these decisions and explain sort of how they turned out, what we like, what we didn't like about them. So the first thing was the past tense action type names. So most Flux examples out there use imperative action type names, right? Like add order or load shipment, or then it'll be like load shipment success or load shipment error. And these actually end up sounding kind of like commands or method names. It's like you're telling the stores what to do. And this was something that was particularly confusing for me at the beginning, especially I came into an existing project and we had some actions that were, like I said, like get shipment. So instead we decided to use past tense action type names. Past tense action types are like a more clear description of a thing that just happened, right? So like clicked view shipment, right? That just means the user just clicked the view shipment button. Or received shipment, that means we just got a shipment back from the server. Or received load shipment error, that means we just got an error back from the server when we were trying to receive a shipment, right? And this is actually a really small thing, but of all the decisions we made, it's the one that I'm the most happy with and the one that I'm most likely to keep doing in other Flux projects. But I mean, not only did we have an easier time naming our actions when we decided to do this, but I think we had a much easier time thinking about Flux in general. And we began to have more insights about how to split up our stores when we started doing this, because it was less like this action is destined for this store. It was just more like, okay, the user clicked this button and then these different aspects of the application that are interested are going to respond to it. And so even if you don't want to use past tense action names, I mean, I realize that there's existing projects out there and you kind of already have a standard, and most things obviously use present tense. I think that you can ask yourself if your action names could make sense in the past tense, right? So if you're deciding to name an action and you have an action called get shipment and you think, got shipment? That's not right. That's not what you're trying to do at all, right? Like I think so even if it's like select shipment, meaning that the user is trying to select a shipment, you can think selected shipment. Yeah, okay, that makes a lot of sense. So I think that this is a pretty cool strategy. Even if you don't even use the past tense names, I think it's a good way to think about it. It can really help you think about the way you split up your stores. So keeping in mind the concept that actions describe things that just happened, we thought that it made sense to trigger Ajax from stores. And not everybody does this, but this is sort of the direction that we decided to go. So actions were pretty simple. They described what happened, like a user clicked on something or we just received something from the server, right? And then the stores would decide what to do, including triggering Ajax. Now this is really important. Even though we were triggering Ajax inside of the stores, Ajax callbacks in the stores never modify the store state directly. Like if there's an Ajax callback inside of the store, it's still very important for it to dispatch a new action if you want to modify the store state as a response to that Ajax call. Otherwise you end up breaking the unidirectional data flow. That's really important to Flux. Like the other stores basically won't know about that update. So to give you an idea of what I mean here, so let's imagine that you have like a view shipment button. And the user clicks on the view shipment button, right? And it dispatches this clicked view shipment action to the dispatcher. And then the dispatcher distributes that to the stores. And then a store, in response to this, decides, oh, okay, I actually need to go talk to the server. So it does this get shipment 1, 2, 3 thing. And then when the callback happens, the store, even though it's right there and it's in the store, it still has to dispatch a new action. So it dispatches a received shipment action all the way back to the dispatcher, which then distributes that to the store. So we had also been confused about combining Flux with React Router. That was one of our initial problems. Ultimately, we created a RouteStore and added a changed route action. Okay, so in our world, stores decide when the route should change in response to actions or in the callbacks of Ajax responses. Because sometimes that makes sense. Like if you create a new thing, you make an Ajax call, you get back in the Ajax callback the ID of the new thing, and then you want to change the route to that new thing. So sometimes a store is going to change the route in the middle of a callback. So route changes actually also result in a changed route action. And then so other stores can listen for that change, can pay attention to the change route action, and they can read route information from the RouteStore. And this is one of the places where wait for makes a lot of sense for us actually, because frequently if you're interested in the route change, the first thing you're going to do is wait for the RouteStore to make sure it loads everything out of React Router. There is actually a possibility, if for anyone who's looking closely, there's actually sort of an odd possibility for like an infinite cascade here. This is like one of the places where we slightly break Flux. And that's because sometimes a store might change the route as a response to an action, and then in the next tick, that will automatically cause a changed route action to be dispatched. And so if you tried to change the route as a response to the changed route action, you could get yourself lost into sort of an infinite loop of route changes. But in practice, we haven't ever had that problem. Another thing that we decided to do was we decided to reduce the action creator boilerplate, right? So with stores doing all of the decision making, most of our action creators were just simple functions, right? Basically, you'd have a function that took a few parameters and it would dispatch an action with those parameters. That was it. That was the whole thing. They wouldn't do Ajax or anything. So for all of those kinds of actions, we actually decided to auto-generate functions. So if we had an action type like clicked view shipment, then we would auto-generate an action function up here for triggering that action. It's pretty trivial. And it had an added benefit for us. At first, we were running into things every once in a while. We would forget to define an action constant. And then you would dispatch actions that had an undefined action constant, and you wouldn't notice that anything had happened. I see someone nodding his head. So this was nice to have functions for each of these things because they actually blow up. I have seen arguments against doing this, about trying to automate the reduction of your boilerplate, but in practice, this worked pretty well for us. So like I said before, when we first started using Flux, we couldn't always articulate what made Flux a good choice, right? Basically, we use Flux because Facebook said so. And it was hard to ignore Facebook's advice, even though we didn't totally understand it. And I think it was important for us as a team to acknowledge that we were in this place, that we were sort of using a technology or a pattern, hoping to avoid problems, but we weren't always sure which problems we were avoiding. And sometimes you just have to start that way and move forward. In February, right as I made first contact with Flux, Dan Abramov wrote an excellent article called The Case for Flux. And at the time, I couldn't distinguish signal from the noise, right? I was reading all sorts of things about Flux. I was Googling about Flux every day. I was reading lots of different articles. And I actually think I even ran into Dan's article, but it was sort of over my head, to be honest. And reading it now, though, I see that it's one of the best explanations out there for why a team would prefer Flux over something like Backbone. In particular, this bit from the article really resonated with me, right? So Dan says, data from the server is not your model. It serves as yet another input, but it can't be the primary model, right? And it's this little tiny tidbit, but when I read that, I realized, like, yeah, that's profoundly important in what makes Flux a good idea. So that insight is made clear, hopefully, by this example, which I've taken directly from Dan's article. So imagine that we have a website like Medium, right? You have a bunch of articles, and each article has a list of likes, okay? So the first 3 likes are displayed at the top of the article. When you go look at an article, you see the first 3 likes. And there's a View More button that lists all of the likes in a continuously scrolling view. So you can see the first 3 likes, you click on View More, you get a new view with like the first 50 likes, and then as you scroll down, they just keep loading, right? And then of course you can add your own like. And this is like a pretty easy thing to imagine. So the thing is, you can't always make assumptions about the relationship between the conceptual model and the server's API, right? Like in this example, maybe those first 3 likes come back with the API call that returned the article, right? But then when they go to the click more button, now the likes are coming from a different endpoint. And it might be a paginated endpoint, right? So, like you get in 10 at a time or 50 at a time or something like that. So what's really going on is that the conceptual, like the pure conceptual model exists within your Flux store or your Flux stores, but like it's not, all the data may not be loaded already, right? But and the data may come from different places, right? So the first few likes could be loaded from the article with the article. Like viewing all the likes loads them from a different paginated endpoint. Liking the article could actually update the likes as well. So let's imagine you click the like button, and then that adds a like to the conceptual model right then, and then triggers some Ajax. And then let's say that Ajax goes wrong, like there's a server error, so your like doesn't go through. There might be a situation where you actually need to roll back the like out of the model. So there's a lot of different ways for those likes to be updated. And so, like I said, what I really like about Dan's point is that data from the server is just another source of input, right? And that source of input is governed by the same rules as user input, right? And of course, the rules governing input in Flux stores is fairly strict and easy to reason about. That's one of the big arguments for Flux, is that you know what's going to happen. You dispatch an action, your stores are all going to respond to that action. They're going to respond in a predictable order, right? And so then when you add the idea that all of your server input is kind of like user input, I think that's where it starts to become powerful, and that's where it starts to make a lot of sense for the way people's applications tend to grow. So at Rock Solid, we know a lot more about Flux now than we did at the beginning of the year. And while I'm generally happy with our approach, there are some nifty tools and some cool ideas out there that could definitely sway me to do things differently in future projects. As the title of the talk implies, there's definitely more than one way to design a Flux application. So one really cool concept that's floating around right now that has piqued my interest is referred to as action replay. Right, so obviously in your Flux application, all of your actions go through the dispatcher, so you could log all of those actions. In fact, you wouldn't even have to log them in the dispatcher. You could have like an action logger store that logged all of the actions. And then if you had all those actions logged, like maybe you sampled some of your users and logged all of their actions, and you were having some weird problem where the state of the application became corrupt and you weren't sure how that was happening, if you had a log of actions, you could like save those and then replay them into the stores in order to recreate that exact situation. Maybe you could replay them one at a time. Dan Abramov has also suggested using something like this for doing like hot reloading. You could sort of save the state of the application by logging all the actions, and then load a new version of the application and replay all the actions into the stores. But this only works if your stores have absolutely no side effects. Like this would not work with the strategy of triggering Ajax from within your stores. So if you were going to make action replay an important part of your, yeah, go for it.
But because you trigger another action from the store, that just kind of work automatically.
Well, so what would happen if you're doing the Ajax from the stores, so like if you think about action replay and you're just recording actions as they come into the dispatcher, let's just imagine the simple situation where someone says like, someone clicks on a shipment, and that's supposed to load the shipment, right? So they click on the shipment, and then that dispatches like a loaded shipment action, right? Or no, sorry, that dispatches a clicked shipment action, right? Then the store is like, oh, okay, clicked shipment, I'm getting ready to load the shipment, and it dispatches the Ajax, right? And then a minute later, the Ajax comes back, and it says, okay, loaded shipment, and now the store knows that, right? But if you recorded that, and you replayed it into that same store, then you would, when you played back to the clicked shipment, the store would trigger Ajax to go load the shipment, but then also the next moment of the replay would replay the loaded shipment. So then the shipment would come back twice, right? So that's why if you want to do action replay, your stores basically have to be pure, like they can't have any side effects. And I think that there's probably some pretty cool things that could be done with this sort of strategy. People are definitely getting along without it, but it's one argument for saying, no, I'm going to do all of my Ajax in my action creators, and then to solve problems like the one that we had at the beginning, you say, oh, well, it's fine for my action creators to read from my stores when they need to. So another powerful concept that pairs well with Flux is immutability, and this is the part of the talk where I have to say the word immutability over and over and over again. So let's see if I can do that without stumbling over it. So obviously, I don't think I have to make all of the arguments for immutability. I think that it gets discussed a lot when we talk about functional JavaScript and functional programming in general. But I want to talk about it as it pertains to Flux. So Flux stores often contain complex nested data structures and update that data in place. That's a fairly standard practice in JavaScript, right? But one good reason to use immutable data structures instead, or to treat your data structures as immutable, is in order to take advantage of something called the PureRenderMixin. So the PureRenderMixin is available as part of the React add-ons. It just comes with React. And it implements should component update to avoid unnecessary calls to render. Right? So one thing about React is that it's kind of crazy because every time something happens, your React app is calling those render functions over and over and over and over again. And I think sort of the revelation of React for a lot of us when we first were introduced to it was, hey, JavaScript is really fast, and it's totally fast to build that virtual DOM again and again and again. Don't worry about it. But if your app gets big enough, unnecessary calls to render can start to be expensive, and some of them might be expensive because they do, various calculations. And so it's actually worth trying to avoid a re-render if you don't need to render. So the way that PureRenderMixin accomplishes this is it just implements should component update. And so should component update basically gets new props and new state, and it can compare the new props to the old props and new state to the old state and decide whether or not the re-render is necessary. And the PureRenderMixin just does this in a very sort of trivial way. It just uses a shallow comparison of old props to new props and a shallow comparison of old state to new state. That just means like equals, 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 right? So the problem is the PureRenderMixin only works out of the box if all of your props and state are simple to begin with, like strings and numbers. If you're using arrays and objects and you mutate them as your application state changes, you can actually miss state changes and fail to re-render. So this is a really good argument for using in all of your Flux stores for treating your data structures as immutable. Like rather than pushing on the end of array, actually slicing the array and then concatenating something to the end of the array. So that way the array is not equal to the previous version of the array. So if you want to do this, if you like the idea of using PureRenderMixin, you'll probably want some sort of a tool for treating your data structures as immutable, right? So like treating JavaScript arrays and objects as immutable can be a pain. I mean, you'll see sample code, especially like with the new ES6 syntaxes, some of it's a lot easier. Like, you can You can use like the splat like the splat ... when you're constructing objects and arrays. And that makes it easier to do it without anything special. But if you're stuck using older JavaScript, or current JavaScript, or actual what we have JavaScript, then doing that can be a pain. So anyways, React comes with a helper available, and it actually just comes with React. It's in the React add-ons, and it's just a single function. It's called update. And what update will do is it takes an object, and then it takes a sort of specification for modifications to that object, and it produces a new object with those modifications, right? So in this particular example, we have a state that has count of 0 and items as an empty array. Then we call update, and we pass in this specification. We would like to set the state to count +1, and we'd like to push these items onto that array. And when we're all done, state hasn't been changed at all. State is exactly what it was before, and state updated is based on state with the modification specified, right? So it's not too complicated, but it's actually pretty convenient to use. It looks a lot like the MongoDB update operators. It supports pretty much everything you'd need to do. And it can do like deeply nested updates and stuff. It's a pretty neat little tool. So that's one of the ways you can take advantage of PureRenderMixin really easily, is you can just decide, okay, all of the state in my Flux stores is going to work like this. But also you might want to do something a little bit more sophisticated. Let's see, so how much time do I have, by the way? Okay, great. All right, I'll go faster. So you might want to do something more sophisticated. So the update function, the problem with the update function is if you get like an array with 10,000 items and you're trying to append something to it, it has to copy that whole array. You can use something like Immutable.js, which is another project by Facebook. And Immutable.js gives you data structures that are actually implemented kind of like the immutable data structures in the language Clojure. So if you have a 10,000 item list and you append something to it, while it looks to you like it's been copied and you have a whole new list, it's a whole new reference, under the hood, the data structure is reused from the old list. So you end up with, it looks like copies, but actually it's pretty memory efficient. It kind of works the way that things like Git work. You know, it doesn't have to have a whole copy of your repository with every change. Another thing that I'm kind of interested in is the reduce store. We were talking about pure functional, sort of pure side effect free stores. Just last month, they finally added some store base classes to the Flux repository. Up till now, Flux has just been the dispatcher. I mean, you know, there's been a lot of other Flux implementations, but the Flux repository only had the dispatcher in it. Anyway, so the reduce store, when you do a reduce store, and I think this is really interesting, all you do is you implement get initial state and reduce, right? So rather than having the big, so what happens is that when an action comes in, that action is passed to your reduce function with your current state. And what you do is you look at the current state and you look at the action, and the idea is to generate a new state by combining those things in a functional way, right? There's no side effects, it's pure functional. If you're not going to respond to the action, you just return the state that you received in the first place. And then the reduce store itself decides whether or not to emit a change, depending on whether or not you actually change the state. So that's just kind of a cool way to do a pure functional store. Also, if I was feeling particularly adventurous, I mean, you know, I'm a JavaScript developer. As JavaScript developers, you're probably all totally bored of everything that came out in 2014, if I have any experience with this field. So if that's the case, these are the two things I would suggest looking at. Redux is by Dan Abramov. He's actually the guy who wrote that article I was talking about. Redux is very cool. It's Flux-like. It's not actually Flux, but it sort of accomplishes the same thing. It's built up around the concept of reducers and of immutability. And then CycleJS is something that I've been looking at a little bit more recently, and it's quite a bit different, but I think it's very interesting. And I think that it's one of the other places where if you were looking at sort of the next thing, that's something you might take a look at. And that's it. That's all I got. Thanks.